Researchers ask students at various stages in their educational career whether they support the building of a mall in Elk Grove. We have the table here. Part A, if one student is selected, find a probability that the student is in college. Probabilities are going to be fractions. For the bottom, we're going to count how many possible people can we choose from. So that's just going to be the total of everybody in our study here. So we'll add up all of the numbers here. So 4 plus 6 plus 1, plus 10 plus 5 plus 17, plus 18 plus 6 plus 5. And I get a total of 72 people. So the bottom is going to be 72. For the top, we're interested in the probability that the student is in college. So how many students are in college? College would be 18 plus 6 plus 5. So all of those people are in college. 18 plus 6 plus 5. 29. Part B, if one student is selected, find a probability that the student is in middle school and the student answered no. Keyword here is the word and. So the bottom of our fraction is still going to be the total of everybody, which is 72. Now, and means at the same time. So I want the people who are in middle school and at the same time said no. So as a hint for these table problems, ands should be a single number in the table. So how many people are in middle school and at the same time said no? That would be 6. So these 6 students are in middle school and at the same time they said no. So 6. Part C, if one student is selected, find a probability that the student is in high school or the student is undecided. So keyword is the word or. The bottom is still going to be the total of everybody, which is going to be 72. Now, or means I want to take all the high school students and combine them together with all the undecided students. So I want all the high school students together with all the undecided students. So all the high school students would be this 10, this 5, this 17. All of the undecided students would be the 1, the 17, and the 5. So all those numbers. Just have to remember that I don't want to count the 17 twice. So usually what I'll do is I'll just start with the first group, which is all the high school students. So 10, 5, 17. So that's 10, 5, 17, and add on the undecided, but remembering not to count the 17 again. So I'm just going to add on the 1 and the 5. Because I got the 17 from the high school students already. So add those together. So 72 on the bottom. Up top, it will be 10 plus 5 plus 17 plus 1 plus 5. And that's 38. Part D, if one student is selected, find a probability that the student did not answer no. So not no. Bottom, still going to be total of everybody, which is 72. For the top, I want the students who did not answer no. So not no's, which will be all the yeses together with all the undecided. So 4, 10, 18. Plus 1 plus 17 plus 5. And I get 55. Researchers collected data on students' class standing and how they did it in their English class. So we have a table. Part A, if one student is selected, find a probability that the student is not a junior. The probabilities will be fractions. For the bottom, it's going to be how many total people can we choose from. So to get the total number of people, we'll just add up all of the people in our table. So 3 plus 17 plus 19. Plus 5 plus 11 plus 7. Plus 1 plus 16 plus 1. and I get 80 people total. Okay, that's the bottom. Up top, we are interested in probably that the student is not a junior, so we want to count all the not juniors. So not juniors would be all the sophomores together with all the freshmen. So everything except for the last row, the juniors row. So 5, 11, 7. So 5 plus 11 plus 7 plus 3 plus 17 plus 19. 62. Part B, if one student selected, find a probability that the student failed or the student was a junior. Keyword is the word or. Bottom will still be everybody, which is 80. Okay, or means I want all the students who failed, combine them together with all the students who are juniors. So all the students who failed would be the 17, the 11, and the 16. So all those students failed. And then all the juniors, which would be the 1, 16, and 1. Okay, I just have to remember to not count the 16 twice. What I usually do is I'll take all the students from first group, which is all the failed, so 17, 11, 16. And then add on the students who are juniors, but remembering not to count this 16 twice. So I'll just add on the 1 and the 1. Okay, add up those numbers up top. To the bottom still 80. Up top, 17 plus 11 plus 16 plus 1 plus 1. 46. Part C, if one student selected, find a probability that the student failed. Bottom will be everybody again. For the top, here we're just interested in students who failed. So failed would be this column, so 17 plus 11 plus 16. And that's 44. Part D, if one student selected, find a probability that the student withdrew and the student was a sophomore. So keyword is the word and. Bottom will be everybody again. So when we talk about and, I want the students who are both withdrew and at the same time are sophomore. Okay, so as a hint, for these table problems, ands should be a single number. So students who withdrew and at the same time are sophomore. So withdrew, sophomore. These 7. So these 7 students are sophomores and at the same time they withdrew. 7. For this question, we're talking about rolling a 20-sided die. So when I roll a 20-sided die, what are all the things I can get? I can get a 1, a 2, a 3, a 4, all the way up to 20. Part A. If a 20-sided die is rolled, what's the probability of getting an even number? So the bottom is going to be the total number of things that we can get, which is going to be 1 through 20. So if you count that, there's 20 different numbers. For the top, we're interested in the probability of getting an even number. So how many numbers are even? Let me go through and circle all the numbers that are even. So even, just count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So those circled numbers are all the even numbers. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For B, if a 20-sided die is rolled, what's the probability of getting a multiple of 5? So the bottom will still be the total of how many different numbers we can get, which will be 20. Up top, how many numbers are multiples of 5? So multiples of 5, I'm going to put a box around. Multiples of 5 means we're just going to count by 5s. So 5 plus another 5 will be 10, plus another 5 will be 15, plus another 5 will be 20. All the numbers that are boxed are multiples of 5. How many are there? 1, 2, 3, 4. Part C, if a 20-sided die is rolled, what's the probability of not getting a multiple of 5? So not getting a multiple of 5. Bottom will still be 20. For the top, we want to count the numbers that are not multiples of 5. Multiples of 5 are the boxes, so how many numbers are not boxed? So this will be all the numbers that are circled together with all the numbers that don't have anything on them. So all the numbers that are not boxed are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 numbers that are not boxed. Part D, if a 20-sided die is rolled, what's the probability of getting getting an even number or a multiple of 5? Bottom will still be 20. Okay, or means I want to take all the even numbers and then combine them with all of the multiples of 5. But remember to not count things twice. Which means I basically want all the numbers that are circled together with all the numbers that are boxed, keeping in mind not to count anything twice. So basically I want to count anything that has a red mark on it. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. Okay, so that's anything that has a red mark on it. Part E, if a 20-sided die is rolled, what's the probability of getting an even number and a multiple of 5? So keyword and means I need both of those things to be true at the same time. So which numbers are even and at the same time multiples of 5? So which numbers are circled and at the same time boxed? So I'm looking for numbers that have both a circle and a box on them. That will be the 10 and the 20. So these numbers have both a circle and a box on them. And there are only 2 of them. Bottom is still 20. This question involves a deck of cards. So here's a deck of cards. Part A, if a card is selected from a standard deck of cards, what's the probability of getting a face card or a heart? Keyword is the word or. For the bottom, how many possible cards can we choose? So what's the total number of cards in our standard deck of cards? So there are 52 cards total. The bottom will be 52. Now, the or means I want to take all my face cards and then combine them with all the hearts. So all my face cards will be the last 3 columns together with all the hearts, which is this 3rd row. So all my face cards together with all the hearts, making sure not to count any cards twice. So all my face cards, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, together with all the hearts, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 22 cards. So all my face cards, last 3 columns, all my hearts, 3rd row, but remembering not to count this Jack, Queen, and King twice. So there's 22 total. Part B, if a card is selected from a standard deck of cards, what's the probability of getting a face card and a red card? Keyword there is the word and. The bottom will be 52 again. Now the word and means at the same time. So I want the cards that are face cards and at the same time red. In other words, I want the red face cards. So red face cards would be Jack, Queen, King, hearts, Jack, Queen, King, diamonds. So that's 1, 2, 3, 4, 5, 6. Part C, if a card is selected from a standard deck of cards, what is the probability of not getting a diamond? So not diamond. The bottom will be 52 again. For the top, I want to count the not diamonds. So not diamonds would be the first 3 rows. Okay, so each row has 13 cards. 13 times 3 is 39. Part D. If a card selected from a standard deck of cards, what is the probability of getting a diamond and a face card? Keyword there, the word and. Bottom will be 52 again. The word and means at the same time. So I want the cards that are diamond and at the same time face. In other words, I want the diamond face cards. So diamond face cards would be just the Jack, Queen, King, Diamond. The three at the bottom here. Jack, Queen, King. So there's 3. Part E. If a card is selected from a standard deck of cards, what is the probability of getting a black card or a king? Keyword is the word or. Bottom will be 52 again. Now, or means I want to combine the black cards together with the kings. So black cards together with the kings. Black cards are the first 2 rows together with all the kings, which is the last column. First 2 rows together with the last column. And then remembering not to count anything twice. First 2 rows, so that's 13 plus another 13, that's 26, 27, 28. So 28 cards. So again, it's the first 2 rows, so those are my black cards, together with all the kings, which is the last column, but remembering not to count these 2 black kings twice. So first 2 rows, that's 13 each, that's 13 plus 13, and then plus these 2 red kings, 28 total.